Voyager 1, launched in 1977, is the most distant spacecraft ever sent from Earth. It is moving away from our planet at a speed of nearly 38,000 miles per hour. Despite being about 15.5 billion miles away, humanity is still able to communicate with it. This raises an extraordinary question. How is it possible to send commands to a spacecraft so far from Earth, and how long will this communication continue? Interestingly, Voyager 2 was launched first, on August 20th, 1977. Voyager 1 followed just 2 weeks later, lifting off on September 5th, 1977. The two spacecraft are almost identical in design and were built with the same ambitious goal: to explore the outer planets of our solar system beyond Jupiter. Rocket engines alone were not powerful enough to send them on such an epic journey. Instead, mission planners took advantage of a rare planetary alignment that allowed the spacecraft to gain speed by using the gravitational pull of multiple planets. Jupiter, Saturn, Uranus, and Neptune were aligned in the same general direction as seen from Earth, an alignment so rare that it will not happen again until the year 2150. Voyager 1 passed by Jupiter and Saturn, sending back breathtaking images. It revealed detailed views of Jupiter's turbulent atmosphere and confirmed the presence of its faint ring system. One of its most remarkable discoveries was active volcanoes on Jupiter's moon Io, the first time volcanic activity had ever been observed beyond Earth. As it continued toward Saturn, Voyager 1 captured stunning close-up views of Saturn's rings and discovered shepherd moons that help maintain their structure. It also found that Saturn's moon Titan has a thick atmosphere made up of nearly 90% nitrogen, a discovery that reshaped scientists' understanding of moons in the solar system. After completing its planetary encounters, Voyager 1 continued its journey toward the outer edge of the solar system. Voyager 2, on a different trajectory, went on to visit Uranus and Neptune, destinations Voyager 1 never reached, returning the first detailed images of these distant worlds. Although Voyager 2 launched earlier, Voyager 1 is now farther from Earth because it is traveling faster. Voyager 1 moves at about 10.6 miles per second, while Voyager 2 travels at roughly 9.7 miles per second. The difference may seem small, but over time it adds up. In just 1 second, Voyager 1 pulls nearly a mile ahead. Both spacecraft have now crossed a major boundary in space, the Heliosphere. The Heliosphere is a vast bubble created by the solar wind, a stream of charged particles emitted by the sun. As the sun moves through the galaxy, this solar wind forms a bubble that is compressed at the front and stretched behind, giving it a distorted shape. Voyager 1 and Voyager 2 have both exited this region. Data collected during this crossing showed a sharp drop in particles originating from the sun and a sudden increase in particles coming from interstellar space. This marked humanity's first direct exploration of the space between stars. While the heliosphere defines the limit of the sun's influence through solar wind, the solar system itself extends much farther. Beyond the heliosphere lies the Oort cloud, a vast theoretical shell of icy objects surrounding the sun. Scientists estimate it will take Voyager another 300 years to reach the inner edge of the Oort cloud, and around 30,000 years to pass through it entirely. Even at these extreme distances, we are still able to send commands to the Voyagers and receive scientific data.
We've got an anomaly on screen 3. Check the trajectory data and confirm the readings.
Each spacecraft is equipped with a dish antenna 12 feet wide, capable of transmitting a very narrow beam of radio waves using just 22 watts of power, about the same as a household light bulb. It takes approximately 22.5 hours for a signal from Voyager to reach Earth. To put that into perspective, light takes just over 1 second to travel from Earth to the Moon, and about 20 minutes to reach Mars. As radio waves travel, they weaken dramatically due to the inverse square law. By the time Voyager's signal reaches Earth, it is faded to less than a trillionth of a watt, and then weakened even further. Detecting such faint signals requires enormous antennas. NASA relies on the Deep Space Network, a global system of giant radio antennas located in California, Spain, and Australia. Each site features massive 230-foot wide dishes, along with several smaller antennas. This global arrangement ensures that at least one antenna can communicate with Voyager at all times, enabling continuous contact. Powering the spacecraft presents another challenge. Voyager does not use solar panels because sunlight is far too weak at such distances. Instead, it relies on radioisotope thermoelectric generators, which convert heat from the decay of plutonium into electricity. At launch, each Voyager produced over 400 watts of power. After decades in space, that output has dropped below 200 watts, forcing engineers to gradually shut down non-essential systems. One of the most famous images Voyager ever captured is a photograph of Earth taken from nearly 4 billion miles away, our planet appearing as a tiny pale dot in the vast darkness of space. Shortly after taking this image, Voyager's camera was permanently turned off to conserve power. Voyager 1 originally carried 10 scientific instruments. Today, only a few remain active, primarily those measuring magnetic fields and charged particles. These instruments continue to provide valuable data about the interstellar environment beyond the heliosphere. As power levels continue to decline, NASA carefully decides when to shut down each remaining instrument. Even after all scientific instruments are turned off, Voyager will still be able to transmit basic data, including its position. Over the years, the spacecraft have faced multiple technical challenges. In 2023, Voyager 2 temporarily lost communication when its antenna drifted off target by just 2 degrees. At billions of miles away, even a tiny misalignment can break the connection entirely. Fortunately, Voyager had been programmed to periodically correct its orientation, and communication was restored automatically. Voyager 1 also encountered problems when a software issue caused it to send data through an inactive computer. After months of analysis, NASA engineers sent new commands that rerouted the data through a functioning system, resolving the issue. NASA continues to plan for future challenges, including potential thruster problems. The Voyagers use small thrusters to maintain their orientation for communication. Over decades, residue can build up and clog these systems. To extend their lifespan, engineers updated the software to fire the thrusters for longer durations but less frequently, reducing wear and adding several more years of operation. Despite all these challenges, both Voyagers continue their silent journey through space. However, as they move farther away, their signals grow weaker. NASA expects that by around 2036, communication will likely come to an end. Voyager 1 and Voyager 2 were originally designed for a mission lasting just 5 years. More than 4 decades later, they continue to operate far beyond their intended lifespan. Their memory capacity is tiny compared to modern smartphones, and their communication speed is extraordinarily slow by today's standards. Yet despite their outdated technology, they have traveled farther than any human-made object in history. Through faint radio whispers across the darkness of space, the Voyagers remain humanity's most distant messengers, still sending signals back to Earth as they journey onward into the unknown. And so, Voyager continues, not as a machine but as a message. A quiet signal drifting through the darkness between the stars, carrying the fingerprints of a civilization that once looked up at the night sky and asked, "What lies beyond?" Long after its cameras fell silent, long after its instruments begin to shut down one by one, Voyager will keep moving. No fuel, no guidance, just momentum and the laws of physics carrying it forward. One day the final transmission will reach Earth, a faint whisper, weaker than anything we have ever listened to before. And then silence. But that silence will not mean the end. Voyager will still be out there, crossing the vast distances of interstellar space, passing through regions no human will ever see, traveling for thousands, perhaps millions of years. It carries no map back home, yet it knows exactly where it came from. A small world, orbiting an ordinary star, in a quiet corner of a galaxy filled with billions of others. Voyager is proof that even with limited technology, even with fragile machines and fading power, curiosity can travel farther than imagination. It reminds us that exploration does not require perfection, only the courage to begin. And as its signal fades into the cosmic background, Voyager becomes something more than a spacecraft. It becomes a reminder that we were here, that we dared to explore, and that our first step into interstellar space was taken not by humans, but by a small golden messenger moving endlessly into the unknown.